Good day, students. You're welcome to JSS School. This is Miss Cynthia. I hope you're fine and I hope you're staying safe. Okay, today we are going to be speaking physics, and our topic today is states of matter. And our specific objective for today, by the end of the lesson, you should be able to define matter, outline the states of matter, outline the change in states of matter, and the factors affecting the change in states of matter. What is matter? Look around you. Anything you see is matter. As long as they are occupying space in your house, as long as they have a mass, as long as they have a definite shape, they are matter. Alright, matter is anything that has mass, weight, and occupy space. So the phone you're using to watch me right now is matter because it has mass and it's occupying space. Now we are going to group this matter into three states. We have solid, liquid, and gas. Now in this state of matter, we are going to be using three properties to define the state of matter. We're going to be looking at if they have a definite shape, if they have a definite amount of matter, that is the mass, and if they take up a definite amount of space, which is the volume. Alright, let's start with solid. Now in solid, the particles of solid, what you're seeing here is nothing but the particles of solid. You can see the particles are closely packed together and their movement is sluggishly. So the motion of their movement, how can we describe their movement, and how can we describe their speed? So we said the particles vibrate in a closed space and they are tightly packed together, meaning that these particles have strong intermolecular force of attraction. So for you to break this bond between these particles of solid, you need to hit them so that they will be loosely packed together. But for now, the particles of the solid are tightly packed and their movement is slow. Alright, let's see our prediction. Do solid have a definite shape? Do they have a definite mass? And do they have a definite volume? Maybe you just guess and you see my answer next. Alright, for solid, they have a definite shape. Your book you're using to write now have a rectangular shape, and it has a definite mass and it takes up a definite volume. So solid have a definite shape, it has a definite mass, and it has a definite volume. So meaning that despite the particles of solid are slow in movement and they are tightly packed, we can say that our prediction is correct. They have a definite volume, a definite mass, and a definite shape. Now let's look at an example of solid. Like I said, it's nothing far from you. Your shoe is solid, your table, your plug, phone, book, whatever you can see around you that you can handle, that is occupying space in your house, is called solid. Alright, now let's talk about liquid, which is the second state of matter. Now the particles of liquid, you can observe that their movements are not restricted like that of the solid. They are vibrating more faster than that of the solid. Okay, how will you describe the motion of these particles and also the speed of the particles? Let's see. Now the particles are close, but they can slide past one another, and their movement is faster than that of the solid. So we say they have a medium speed. Now let's see our prediction. If liquid have a definite shape, if it has a definite mass and a definite volume. So just guess now and you see my answer next. Liquid do not have a definite shape because it takes the shape of the container. You will see in the next slide what I mean by that. Does liquid have a definite mass? Yes, liquid have what? A definite mass, and it also have a definite what? Volume. Okay. Now let's see liquid in the container. You see this container is cylinder. These are different form of what? Of a cylinder. So this cylinder here has what? A water inside, and this also have a different shape. This also have a different shape. So that's what I mean, that liquid does not have a definite shape. It assumes the shape of the container. If you put a liquid inside what? A cylinder here, the shape of the liquid is what? Is in the form of what? The shape of the cylinder. Now if you put it what? In a coily shape, it assumes the shape of what? Of that object. Okay, just like in this case, we put a cat inside a liquid, so the cat is also a liquid because it's taking what? The shape of what? Of the container. So now I believe you understand what we mean, why we said liquid does not have a definite shape. It assumes the shape of what? Of the container. Okay, so let's see examples of liquid: river, juice, cold, your gas, fuel, your detergent, liquid detergent. They are all what? Examples of what? Of liquid. Okay, so let's talk about what? Gas. Oh, now you can see the particles of gas haphazardly moving randomly. They are not even organized. They are vibrating with speed. So they are eager to what? To move out, to leave what? Their vicinity. So the movement of the particle, they are not what? Tightly packed at all. The particles are far behind, and their movement is what? Is fast. The speed of this particle are what? Are faster than that of the solid. They are faster than that of what? The liquid. And also the particles of this gas, they vibrate more than that of the particles of what? Of liquid and what? And solid. Okay, so let's see if our prediction is fine. For gas, do gas have a definite shape? No, gas do not have a definite shape. Let me tell you why. If you're cooking, maybe you are boiling water, you cover the pots of your water. Now maybe you take 5 minutes, your water start boiling, you open the cover of the pot, you see what? A vapor coming out from what? From your boiling water, and that vapor is what we call what? A gas. Do you see? Do we have a definite shape? There is no shape at all, so you don't even think about it. You just write no, that gas do not have what? A definite what? Shape. Do gas have a definite mass? Yes, they have a definite mass, but they do not have a definite what? Volume. Now, examples of this gas, you see, the refinery. For you to blow a balloon, what makes the balloon to blow and move up is what? Is gas. So the air you put surround and cover what? The space of the balloon, and what? That's why it's what? Able to shoot up. Now, even our cooking stove is gas, and our pressure gas are all what we see around us. So these are all examples of what? Of gas. All right, so let's look at our summary of the state of matter. So far we've achieved what? Our second objective. We are good in matter. We all know what matter is. The state of matter: solid. You see the particles of solid, they are tightly packed together. The particles of liquid, they are closely packed together, and that of gas, they are loosely what? Packed together. So by now, I'm sure you can give me at least 3 examples of solid, liquid, and gas. Okay, just a review of what we've been discussing. For solid, the definite shape is yes, it has a definite shape. Liquid does not have a definite shape. Gas does not have a definite shape. So this is just a summary of what we've just discussed. And also, for the motion of the particle and for the speed of the particle, this is also what? The summary. So endeavor to write this down in your notes clearly. Now let's go to what? Our third objective. Okay, let's talk about this first before we move to our third objective. I'm just giving you more summary. I just want you to have a well understanding of matter. So state of matter, one of the form that matter take are solid, liquid, and gas. And for solid, matter has a fixed volume and a fixed shape. For liquid, matter have a fixed volume but does not have a fixed shape. And for gas, matter has no fixed volume but it has no fixed volume or a fixed shape. Okay, so that's all what you know about state of matter. I've given you enough summary for you to understand better the state of matter. So let's talk about these changes in state of matter. Now you can see, first of all, here is what is my solid. I have 3 cylinders, and in this cylinder, the first one I put what? A solid. A solid can be what? A cube, a ice cube. Okay, it's a solid. And this is just my water, that's liquid. And in the third cylinder is what? Is my gas. So what's happening here? For solid to change to liquid, something must occur. Now that is what we refer to as what? The change in state of matter. What happened when solid changed to liquid? What happened when liquid changed to solid? What happened when gas changed to what? Solid, and all that. So we're going to understand it here. Now, for solid to liquid, what's taking place is what? Is melting. For a solid to change to liquid, it has to what? Melt. For example, if you bring out what? Your block water inside your refrigerator, if you bring it out from the refrigerator and allow it to settle down for like an hour, you see the ice will melt down. So in that process, what the change of state is that is taking place is what? Is melting point there. So another example is maybe your mommy put a soup inside the freezer and she wants to make use of the soup at night, so she have to remove it what? Very early in the morning, so that what? She'll be able to what? To get the soup. So what's taking place is what? The soup is what? Is melting, and it is being subjected to what? To temperature or heat that will cause it to what? To melt. So for solid to change to liquid is what? Melting. That's the change of what? Of state. Now, what about from liquid to solid? If you just put your normal water in the freezer, you find that what? It freezes. Okay, it has changed back to what? To the ice. So what's taking place is what? Is freezing. That liquid has freeze to what? To solid. Now, what about from liquid to what? To gas. From liquid to gas, we call it what? Vaporization. An example of vaporization, I told you, when you're cooking or when you're boiling water, you allow the water to boil. Of course, you have to cover the pot of your water or your kettle. So after the water is boiling, you remove the cover and you find that what? Vapor is what's coming out from what? From your cooking water. So what is taking place? The liquid has changed to what? To gas. Now, from gas to liquid, we call it what? Condensation. Now, if you imagine you in your bedroom, I'm trying to give you an example that you understand condensation. Imagine you are in your bedroom and you're bathing with what? With warm water, okay? And after shower, you kind of get out from the bathroom and your bathroom have what? A mirror, okay? So the water you use to take your bath is warm, like it's kind of a little bit hot. So after you've taken your bath, you try to look at the mirror and you find out that there is a fold, like a bead in the mirror. So when you use your hand to wipe that fold, you find that what? Is watery. Water is what? Coming out. So in that process, the vapor from your water rises up and what? And display in what? In your mirror. It just disperses at the surface and it finds a better place to stay, which is what? Your mirror. And that's why whenever you finish taking your bath with warm water, you take the mirror, you look at the mirror, you see what? It is covered with what? A fog. That is what? A gas. And when you take that, a fog, you will see that it is what? Is liquid. So what is taking place at that point is nothing but what? Condensation. Okay, the thing is, you don't just worry about the explanation of all this. Just know that from solid to liquid is melting, from liquid to solid is freezing, from liquid to gas is vaporization, from gas to liquid is what? is condensation. When you get to senior secondary school, you're going to understand more better. But just know that these are what the change of state of matter. From solid to gas, we talk about what sublimation. Example, a solid to change to gas, we have what we call a camphor, right? If you leave that camphor, you see it will be going up, and you see that it will melt. Okay, it will be going up and filling up the surface of the room wherever you kept it. So from gas to solid is what is deposition. So all these are what change in state of matter. So from now, I just want you to master that of what solid to liquid, liquid to solid, liquid to gas, and gas to liquid. Okay, and try to give at least one example of them. All right, so that's what the changes in states of matter. Now our next objective is factors affecting this change in state of matter. We have two factors that affect the change in state of matter. The first one is temperature, and the other one is what is pressure. Okay, if you remember very well, I said for your solids to change to liquid, you have to what? Heat it. That means that heating, your solid is undergoing what? A rise in what? In temperature for it to what? To melt. So yeah, I said in solid, on increasing the temperature, there will be an increase in the number of collisions between what? Particle. As a result, the intermolecular force of attraction will decreases. Okay, remember the solid are tightly packed, right? Now if you heat the particles of that solid, the intermolecular force will decrease, and they will be loosely packed and free to move. So in that process, your ice block is what? Is melting. So the state of the solid will change to what? To liquid. For example, ice upon heating, change it to what? To liquid, just the way I've explained earlier. So the second factors that affect the change in state of matter is what? Is pressure. Now is the reverse. Now an increase in pressure will cause what? The particles to be what? Closely packed together. Hence the state of matter will change from what? From liquid to what? To solid. Because of what? The increase in what? In pressure. Now for example, when we freeze liquid, it changes to what? To solid. So these are the two factors that affect what? The change of state of matter. Okay, I hope you've understood what matter is, the change of state of matter, factors affecting matter, and how particles of this matter behave. Alright, so your assignment, I want you to give me two examples of the following change of state of matter: solid to liquid, liquid to solid. So give me two live examples apart from the one I've told you here. Okay, so just think out of the box and give me two examples. And in number 2 says, in tabular form, state 3 difference between solid, liquid, and gas. Okay, so this assignment is very simple. You can just do it right now and you are done with your work. So try to go through this video 2 or 3 times for better understanding. If you have any question to ask, feel free to ask me a question. Just a recap of what we've done today. Matter is anything that occupies space. Matter is anything that has weight, mass, and what? You might also have what? A volume, depending on what? On the state of what? Matter. And we say we have 3 states of matter, which is solid, liquid, and what? And gas. And we clearly define what this state is using what? 3 prediction, which is what? Their shape, their weight, and their volume. And next we discuss about the change in state of matter. For a liquid to change to solid, what's happening? For a gas to change to liquid, what's happening? Something is what is taking place. And we talk about factors that affect what? The change in state of matter. Increase in pressure will change it from solid to what? To liquid. And increase in temperature will be from solid to liquid, and increase in pressure will be from what? Liquid to what? To solid. So have a nice day and stay safe. Bye.